In this lecture we will solve a problem using Bellman Ford algorithm. Here we have been given a graph, this one. Here some of the edge weights are negative. So if we are asked to apply single source shortest path algorithm on this graph, then we cannot apply Dijkstra because Dijkstra never allows negative edge weight. Okay, so we have to apply Bellman Ford if we have been asked to apply single source shortest path algorithm. In this graph, assume that S is a source. And before proceeding to the algorithm, before applying the algorithm, let us analyze the graph that how many edges are there. S2t is the first edge, S2y is the second edge, S2t, S2y. Then T2x, T2y, T2z are three edges, T2x, T2y, T2z, among which T2z is a negative edge weight holder. Then x2t is another edge, which is also a negative edge weight. Z2s, Z2x, these two are another edges, and y2x, it is a negative edge weight holder edge, and y2z is the last edge. So these are the set of edges present in the graph. Okay, we assume that S is the source vertex. Now we will apply Bellman Ford to find out the shortest paths from S2t, S2y, S2x and S2z, where S is the source vertex. Okay, so we have to calculate shortest path from S to other vertices. So first part is basically called the initialization of the graph, and you know that initialization means d parameter value for all the vertices will be assigned to infinity and pi parameter value of all the vertices will be assigned to nil. That means no vertex present in the graph has their predecessor and no shortest path estimate have been calculated yet. That's why d parameter value, which is called shortest path estimate for the vertex, is initially assigned as infinity, and pi value of all the vertices, which is called the predecessor, it is assigned as nil. Let us again tell that S is a source vertex, so shortest path estimate for source is assigned to 0, that is S dot d will be 0, and the entire process is called the initialization process. So this is basically, so S, T, X, Y and Z, these are the 5 vertices. We have maintained the sequence as S, T, X, Z and Y. We are moving to the clockwise direction, S, T, X, Z, Z and Y. These are the 5 vertices. Initially their d parameter value is infinity, their pi parameter value is nil. We have decided S is the source vertex, so d parameter value of the source will be 0 and remaining are infinity, then their pi parameter value are nil. So this is the first step. Step 2. We know that the graph is of having total 5 vertices. So there will be 5 minus 1, 4 iteration, and under each iteration you have to apply relaxation for each edge. Okay, this task we are going to do now. So we have mentioned here, as we have total 5 vertices, so total number of iteration will be 5 minus 1, 4, and for each iteration the algorithm relaxes edges, progressively decreasing the estimate v dot d. That means under each iteration you have to apply relaxation for all the edges present in the graph. That means you have to apply relaxation for this entire set under first iteration, under second iteration, under third iteration and under fourth iteration. Okay, as the graph consists of 5 vertices, so there will be total 4 iterations, and under each iteration you have to apply relaxation for each edge. So this task is now going to be performed here. So this is the first table which you have already formed after initialization process is done. Apart from S, that means apart from source, all vertices d parameter value is infinity and pi parameter value is nil. Now, so we are at, suppose we are at the first iteration. So what are the edges? S2t, S2y, T2x, T2y, T2z, x2t, z2s, z2x, y2x and y2z. We first pick up the edges from S. Then we will go for picking up the edges for T. Then we will pick up the edges for X. Then we will pick up the edges for Z. and at last we will pick up the edges for y. We will maintain this sequence. So first two edges for s is s2t and s2y, s2t and s2y. We will cover all edges, but we make partition for the edge sets. For first set is s, for second set is for t, third set is for x, fourth set is for z, and last set is for y, so that you can easily manage the entire process. So for s, what is d parameter value for s is 0. What are the edges for s? s2t and s2y, s2t and s2y. What are the d parameter value of t and y? t dot d is infinity and y dot d is also infinity. What is their pi parameter value? T dot pi is nil and y dot pi is also nil. Why I am considering their d value and pi value? Because I have to apply relaxation from s to t and s to y, and you know that relaxation requires d parameter value and relaxation also requires pi parameter value, because the formula of relaxation, if you go through, you will find that relaxation of u v w, in our example it is st and their edge weight, v dot d greater than u dot d plus w of uv, then this and this. So you must have the corresponding d parameter value. So we are applying relaxation from s to t and s to y. So we have to check whether t dot d is found greater than s dot d plus w of s to t. W of s to t means 6. What is t dot d? We have noted it infinity, greater than. What is s dot d? It is 0. And what is w of s to t? W of s to t is 6. So infinity greater than 0 plus 6. 0 plus 6 means 6. So infinity is found greater than 6. So t dot d is found greater than s dot d plus w of st. So definitely t dot d is receiving the new value, that is 0 plus 6, because infinity is greater than 6. It is true. So if it is true, relaxation says yes, there is a successful relaxation. You can reduce the d value of t from infinity to 6. And due to which vertex? Due to s, because there was an edge from s to t. Due to the presence of s, you can reduce the d parameter value of t from infinity to 6. So definitely its pi value is changing from nil to s, because s is the responsible predecessor, due to which the d parameter value of t is decreasing from infinity to 6. The same formula is applicable for y. Check y dot d is greater than s dot d plus w of s to y. S to y distance is 7. So infinity is found greater than 0 plus 7, which is 7. So new d parameter value of y will be 7, and obviously its pi parameter value is changing from nil to s, using the same logic which you have applied for t. So the new d value of t is 6, new d value of y is 7, new pi value of t is s, and new pi value of y is also s. So we are updating the table. There is no change for s, because you are applying relaxation with respect to s. Only the change is for t and for y. It was infinity, now it is 6. It was nil, now it is s. It was infinity, now it is 7. It was nil, now it is s. And we have mentioned s superscript of 1, that implies under first iteration we have completed all the edges from s. So that's why it is represented as s1. So under first iteration all the edges from s is complete. Okay, then you have to use this table. Forget about the first one. You use the updated one for considering the other edges. We have completed first two edges. Next we will proceed for the edges from t, t2x, t2y and t2z. So we have made a table for t. t2x, t2y, t2z are 3 edges. What is the last updated value of t dot d? T dot d, at first it was infinity. After the first part is over with respect to s, t receives the new d value, which is 6. So I told in my algorithm sections for Bellman Ford, I told once an update is found, you have to propagate the update. So you have to accept the new d parameter value of t for further processing. So d parameter value of t is 6. What are the edges? t2x, t2y and t2z. So you need to have the d value of x, d value of y and d value of z. D value of x is infinity, d value of y is 7 because it is already updated, and d value of z is found infinity, and note their pi value x dot pi is nil, y dot pi is already updated as s, and z dot pi is still nil. Now apply relaxation with respect to t, to its adjacent. To its adjacents means to the edges basically. To its adjacents means s to t, s to y, yes, they are adjacent, and you can say at to the edges also. That means t2x check, t2y check, and t2z check. Okay, so check the formula. X dot d is found greater than t dot d plus w of t2x. And what is t2x? T2x is 5 unit. So what is x dot d now? X dot d is still now infinity, is greater than t dot d is 6 plus distance from t to x. T to x is 5 unit. So infinity is found greater than 6 plus 5, 11. So new x dot d is reduced from infinity to 11. So once it is found reduction of its d value from infinity to 11, so definitely its pi value is changing. Its earlier pi value is nil. Due to the presence of t, you can reduce its d value from infinity to 11, so the pi value will be t, because t is the responsible predecessor. Okay, so now check for the second edge, that is t to y. Y dot d is greater than t dot d plus w of t to y. What is y dot d? Y dot d is 7. What is t dot d? T dot d is 6. What is w of t to y? Okay, take the graph. T to y, it is 8 unit. So 7 is greater than 6 plus 8. 6 plus 8 is 14. So this relationship is found false. So no relaxation for y with respect to t. So for this edge, there is no successful relaxation. Okay, so no change of y dot d and no change of y dot pi. The last case, there is a new value of x dot d, and that's why there is a new value of x dot pi. But in this case, no successful relaxation, because this relationship is found false. So no change of y dot d and no change of y dot pi. And then check the last stage, t to z. So you have to check whether z dot d is found greater than t dot d plus w of t to z. What is the distance of t to z? T to z is minus 4 unit. So formula says infinity, because z dot d, yes, it is infinity, greater than t dot d, it is 6, plus w of t to z, it was observed as minus 4. 6 minus 4 is 2. Infinity greater than 2. So definitely there is a successful relaxation with respect to t to z. So the new d value of z will be 6 minus 4, that is 2. So definitely the pi value of z will be t, because due to t you can apply successful relaxation for z. Okay, so only two changes. One changes for x and another changes is for z. And first iteration, all the edges from t is complete. That's why I mentioned t superscript 1, like s superscript 1. Okay, so only the change is found for x. It was infinity and nil, now it is 11 and t. Another change is found for z. Earlier it was infinity and nil, now it is 2 and t. No change for y, because there is no successful relaxation for y with respect to t. So y is same as the previous table, that is d value of y and pi value of y is same as the previous table. And why there is no change for s? Because there was no edge from t to s. Only there are three edges, t to x, t to y and t to z. There was no edge from t to x, t to s, there was no edge. So that's why there is no change for s. There might have been any change, there may not be any change, but as there is no direct edge from t to s, so no consideration for s with respect to t here. Okay, fine. So this is the updated table. So we have already covered first two edges, then next three edges. Total 5 edges we have covered. Now take the third edge for x to t. Okay, now we'll go for the third edge for x to t. Okay, so let it, now the use the updated table. S1 T1 done. That means under first iteration S and T task is over. That means all edges from S and all edges from T is covered. Now we will pick up X to T, this edge, X to T. Okay, X to T, this is an edge. So take the D value of T. D value of T is 6. Pi value of T is S. Now apply relaxation with respect to S to its adjacent. That means check T dot D is found greater than X dot D plus W of X to T. T dot D current value is 6 greater than X dot D current value is 11 plus W of X to T. X to T is minus 2. So 6 greater than 11 plus minus 2. 11 plus minus 2 is plus 9. So 6 greater than 9 is false. So no relaxation and no change of T dot D, because T dot D earlier was less than the current estimate. So that's why T dot D is no change of T dot D, and as no change of T dot D, so definitely no change of T dot pi. So the last table and the new table is same, only there is a slight modification, X superscript 1. This implies under first iteration the edge from X has already completed the relaxation process. Okay, though unfortunately there was an unsuccessful relaxation. Okay, then consider the next set. We have completed S2T, S2Y, T2X, T2Y, T2Z, X to T finish. Then we'll pick up Z to S and Z to X. Okay, so now Z to S and Z to X. Okay, because Z to S there is an edge, Z to X there is another edge. Okay, so what is the D value of S? 0. What is the pi value of S? Nil. So for X, what is the D value of X? 11. What is the pi value of X? It is T. So apply relaxation with respect to Z to its adjacent, means to S and X. To check, S dot D is greater than Z dot D plus W of Z to S. What is Z to S? It is 2 unit. Okay. What is S dot D? It is 0. Greater than Z dot D, it is 2 plus W of Z to S, it is also 2. So 2 plus 2, 4. 0 greater than 4 is false. So no relaxation. So definitely no change of D value of S and no change of pi value of S. Similarly, go for checking of X dot D. Yeah, X dot D is greater than Z dot D plus W of Z to X. What is Z to X? Z to X is 7 unit. Okay. What is X dot D? It is 11. Greater than, what is Z dot D? Z dot D is 2 plus W of Z to X. Z to X is, Z to X, what we have got? Z to X is 7. Okay, so 11 greater than 2 plus 7. Yes, 11 greater than 9. So the new D parameter value of X is reduced from 11 to 9. And pi parameter value of X was earlier T. Now the responsible predecessor is Z, due to which the T parameter value is reducing from 11 to 9. So new pi parameter value of X will be Z, because Z is the responsible predecessor. So only there is a change for X. So compare this table. Okay, only there is a change for X. Earlier it was 11 and T. Now it will be 9 and Z. 9 and Z. And there is no change for S because no relaxation. And we were checking Z to S and Z to S. So Z is the responsible vertex. So J completes its execution under first iteration. So Z1 is mentioned here. So Z task is complete. Okay. Now we have covered first 2 edges, next 3 edges, next this edge, next 2 edges, and we have to cover the rest 2 edges, Y to X and Y to Z. Okay. So use this updated table, and there are 2 edges, Y to X and Y to Z. So Y is the main vertex for which you have to go for relaxation with respect to Y to X and Y to Z. If there may be successful relaxation, there may be unsuccessful relaxation, we have to check it. X dot D, the current value of X dot D is 9, because I told you repeatedly you have to use the updated table. X dot D is 9 and X dot pi is Z. What is Z dot D and Z dot pi? Z dot D is 2 and Z dot pi is T. So now proceeding to next, Apply relaxation with respect to y to its adjacent means x and z. So first go for x. X dot d is greater than y dot d plus w of yx. X dot d is 9, y dot d is 7, and w of y2x. Y2x it is minus 3 units. So definitely there is a chance. So 9 is greater than 7 plus minus 3. Yes, 7 plus minus 3 means 4. So again you can reduce the value of x dot d, which was 9. Now it will be 7 minus 3, that is 4. 9 greater than 4 is true. So again you can decrease the value of x dot d from 9 to 4. And what will be the responsible predecessor? Due to the presence of y, you can reduce the d parameter value of x from 9 to 4. So responsible predecessor is y, because you are applying relaxation with respect to y to x. So x dot pi, earlier it was z, new it is y. Okay, there is a change. And check for z. Z dot d is greater than y dot d plus w of y to z. Z dot d is 2, greater than y dot d is 7 plus w of y to z. Y to z is 9 unit. So 2 greater than y dot d is 7 plus 9, 14. 2 greater than 14 is false. So no relaxation. So no change of z dot d and no change of z dot pi. Only there is a change of x dot d. Earlier it was 9, now it is 4. Earlier x dot pi was z, now new pi value of x is y. So there is a change for x. X was 9, now x is 4. Pi value of x was z, now the pi value of x was y. And now y completes all of its edges. So y1 we have mentioned here. So all edges are complete. First iteration is done. So first iteration is complete. Use the last updated table for entering into the second iteration, because we have to cover total 4 iterations. Keep it in mind. Okay, now the second iteration. Second iteration, again we have to start or repeat the same process which we have applied for first iteration or the first iteration. Okay, again the edges are s2t, s2y, t2x, t2y, t2z, x2t, then z to s, z to x, and finally y to x and y to z. So let us pick up the first two edges, s2t and s2y, using their d value s2t, s2y, their d value 6 and pi value s, d value s, d value y dot d it is 7, sorry, it is a mistake, it is 7, and y dot pi is s. Okay, so you have to check it. T dot d, which is 6, greater than s dot t 0 plus w of s to t, it is 6. 6 greater than 6 is false, so no relaxation. No change of d and pi value for t. Check y dot d. Y dot d is 7, greater than s dot d is 0. 0 plus w of s2y. W of s2y is 7. So 7 greater than 7. Again it is false, so no relaxation. No change of d value of t and d value of y with respect to s. So no change, but s completes all of its edges under iteration 2. That's why it is a slight change. S1 earlier, now it becomes s2. That means s completes all of its edges under iteration 2. Now we will pick up 3 edges from t: t2x, t2y and t2z. Okay, tx, ty, tz. We will use the updated d parameter value of t. Updated d parameter value of t is 6. Okay, so now what is x dot d? X dot d is 4. This one. What is x dot pi? X dot pi is y. What is y dot d? Y dot d is 7. What is y dot pi? Y dot pi is s. What is z dot d? Z dot d is 2. And what is z dot pi? Z dot pi is t. Okay, so apply relaxation from t to x, t to y and t to z. So take up first edge t2x. So x dot d is greater than t dot d plus w of t to x. X dot d is 4, greater than t dot d is 6 plus t2x. T2x is 5 unit. So 4 greater than 6 plus 5, 11. So it is false. so no relaxation. You have to check this one and you have to check the third one. In these three cases, there will be no successful relaxation. So no change of d parameter value for x, d parameter value for y, and d parameter value of z. As their d parameter is not changing, so definitely there is no scope of changing their pi parameter value. So t completes all of its edges. That's why it is mentioned as t2. Under second iteration, t finishes its execution. That means t completes all of its edges from t to the vertices x, to the vertices y, and t to the vertices z. Okay. Now we'll pick up the next edge, that is x to t. Okay. X to t is the third edge. Third set we are considering x to t. What is x dot d? X dot d is 4. Okay. What is t dot d? T dot d is 6. What is t dot pi? T dot pi is s. Now check whether relaxation is done or not. What is t dot d? T dot d is greater than. What is x dot d? X dot d is 4 plus w of x to t. Yeah. X to t is a negative edge, minus 2. So you may expect that there is a successful relaxation. Check it. T dot d is 6 greater than. X dot d is 4 plus w of x to t is minus 2. So 4 minus 2, 2. Yes, 6 greater than 2. Successful relaxation for t with respect to x. So new d parameter value of t is reduced from 6 to 2, and definitely its pi value is changing from s to x, because x is the responsible predecessor by which shortest path estimate for t is reducing from 6 to 2. So new t dot d value is 2, new t dot pi value is x. Okay, so there is a change for t. Yeah, there is a change for t. Earlier it was 6, now it is 2. Earlier it was s, now it is x. And all of the edges from x is complete under second iteration. That's why I mentioned as x2 here. Okay, now go for, we have completed s2t, s2y. We have completed t2x, t2y, t2z. We have completed x to t. Now we'll pick up z. And there are two edges, z to s and z to x. Okay, now take this one, that is z to s and z to x. What is the last updated d parameter value of z? It is 2. And pick up s and x and identify their d value. S dot d is 0, s dot pi is nil, z dot d is 4, z dot d, I'm sorry, there is a mistake here, x dot d, x dot d is 4. I forgot it is, I wrongly mentioned it is z. No, z to x means you have to pick up the d parameter value of x here. So x dot d is 4, yeah, and x dot pi is y, and z dot d I mentioned it is 2. Okay, you have to check whether there is a relaxation from z to s and z to x or not. Z to s, that means s dot d is greater than z dot d plus w of z to s. S dot d is 0, z dot d is 2, and w of z to s. Z to s is 2 unit, this 2 unit. So 0 greater than 2 plus 2, 4, which is false. So no relaxation for s. Similarly, if you apply this formula and check, you will find no relaxation for x. So no change of d parameter value and pi parameter value of s and x. So this is the table. No change for s and x. Only there is a change that z1 was there. Now it becomes z2, because all the edges from z are completed with under iteration 2. Now the last two edges are there, y to x and y to z. So y to x and y to z. Y dot d, as per the last table, it is 7. What is x dot d? X dot d was 4, x dot pi was y, z dot d was 2, z dot pi was t. Now check. After checking, it is observed that x dot d greater than y dot d plus w of y to x. X dot d is 4, y dot d is 7 plus w of y to x. Y to x is minus unit, though there is a minus unit, but unfortunately there is not a hopefully successful relaxation, because 4 is greater than 7 minus 3 is 4. 4 is greater than 4 is false, so no relaxation. And similarly z dot d is 2 greater than y dot d is 7 plus w of y to z is 9 unit, not possible at all. So 2 greater than 7 plus 9 is 16. So 2 greater than 16 is false, so no relaxation. So fortunately there is no relaxation for x and z with respect to y, but there is on this light change for it was y1. In the next table you will find that y2 here, and no change for the values. Okay, now second iteration is complete. We have still 2 other iterations remains. I have calculated it manually. It is my request to everybody to calculate it manually and take the decision. Where you will find the updated table after third iteration will be a slight change for z. New d parameter value of z will be -2. It was +2, it is -2, and new pi parameter value, and pi parameter value was t, and in the after third iteration it will also be t. That means with respect to vertex t, z got another successful relaxation and its d parameter value was reduced from +2 to -2 with the same vertex t. So no change of predecessor but the change of d value. Okay, same strategy we have applied. We have started from s to t, s to y and so on, and we have completed last for y to x and y to z, and finally we have got this table. And I have calculated the fourth iteration also, and fourth iteration I have found no change. That means no successful relaxation. You will not get any change in fourth iteration. You will not get any change in fourth iteration. Third and fourth iteration will be same. Hence the updated table after fourth iteration is same as the updated table at the third iteration. Okay, you will not get any change in fourth iteration. Okay, so 70% of the task is complete. Now check for negative weight cycle. I told it after all the iterations is complete, you have to check all edges. That means for each edge present in the graph, you have to check whether still there is any relaxation possible or not. That means you have to pick up all the edges. And what are the edges? S to t, s to y, t to x, t to y, t to z, x to t, and then z to s, z to x,